Namaste. I, JVN Neha Sharma, Jyoti Vidyapeeth Women's University, Department of Science and Technology, Faculty of Education and Methodology. So our today's class topic is backpropagation algorithm. So here the outline of the today's class. First part is introduction, then the algorithm, then its applications. Right. So basically, artificial neural network are the attempt to model the machines and train the machines, and you have to believe that processing take place like human brain, right? So like Google self-driven Google cars and speech recognition, face recognition in FB, Uber, automatic fare calculation, live online support chat system, chatbots, right? So all these are working on the AI, artificial intelligence, and the machine learning algorithm, right? So here we today we cover a very important algorithm, backpropagation, which is also implemented in gradient descendant algorithm, right? So basically, gradient descendant algorithm is worked on backpropagation algorithm, right? So okay, let's get started. So backpropagation is an abbreviation for the backward propagation of errors. So basically, what is the name shows here is backpropagation. So basically, here what is backpropagate? That is error. Here, error is propagate back to the network, then again we recalculate the weight associated with the nodes, and then we have to minimize the error and enhance the performance of the network. So this is the whole scenario of, or to say summary of the backpropagation and the idea behind the backpropagation, right? So the method is calculate the gradient of a loss function with respect to the weight in the network. The gradient is fed to the optimization method, which in turn uses it to update the weight and in attempt to minimize the loss function and minimize the error and improve the performance, right? So the method calculate the gradient of loss function in gradient descending problem with respect to all the weights in the network. So backpropagation algorithm can be divided into the two phases here. Basically, it is divided into three phases because uh, okay, here divided in two phases based on the propagation and the weight update. So right, okay. So we have to first run the whole algorithm of feed forward network. We have to first propagate the data from left to right, from the start till end, means its input layer, then multiple hidden layers, then the output layer. So first our data is flown from left to right, then we calculate the error, the difference between the actual output and the desired output. If it is large, then we have to again uh, propagate the error back to the hidden layer and then to the input layer, right? Then again the input layer data propagate to the hidden layer, then again calculating the weight on the multiple hidden layers, and again sum up all this data and then go to the output layer, then again check the error. If it is high, then again error back to the internal network. So this process goes on and on until we get our desired output. Get it? So forward propagation of training pattern input to the neural network in order to generate the propagation output activations. So here is a one term which is activation function, right? So activation function is basically what? Right? In neural network, there are two terms: activation function and the cost function. So activation function basically define the output of the node based on the weighted set of inputs, right? So like non-linear activation function, linear activation function, there are various kind of activation functions like binary step, sigmoid, and TANH and ReLU and many other activation functions. And the cost function measure the performance of the whole network, basically. So, so cost function is basically measure the performance of the whole network, right? So how the cost function calculate the performance of the whole network on the basis of calculating the weight and the bias, right? So okay. So forward propagation of training pattern input through the neural network in order to generate the propagation output activation, back propagation of the propagations output activation through the neural network using the training pattern target in order to generate the deltas, the difference between input and output values of all output and hidden neurons, right? So second is weight update. Multiply the output and the input activation to get the gradient of the weight and then get the percentage in the weight, right? And update the weight. So this is the algorithm of the backpropagation, right? So here we can see first is to compute the error till the end. I also give you handwritten notes for this backpropagation algorithm so that you can see the clear picture about the backpropagation algorithm. So here we just compute the error at the output, first forward pass all the data in first second step you see here prediction. uh, First set the prediction and the actual output, prediction output and actual output. It calculated on the very first step in beginning in the forward pass, so basically feed forward network propagation, right? So then we compute the error, the difference between the predict output and the actual output at the output layer. Then again, if the error is high, then uh, error is propagate back to the hidden layer. So this is backward pass, here you can see, and then compute the weights on the hidden layer for all weight from hidden layer to output layer, right? Then backward pass continue to the input layer. Now compute wi for all the weights from input layer to hidden layer and then update the weight, right? So input layer not modified by error estimation until all example classified correctly or another stop, another or we get our desired output, right? So it repeated again and again in iteration until we get our desired output. So we just adjust the weights here and until we get the desired output and increase the performance. So this is all about the back propagation algorithm here, right? And propagating forward, as we all know, feed forward. So first it goes from input node, it goes from input node to internal node, calculate the weight on internal nodes or to say hidden layer nodes, right? And then it goes to the output nodes and calculate uh, the final output there, right? And the application of the backpropagation algorithm is speech recognition and the image recognition, right? So hope you understand the concept of backpropagation algorithm. Basically, it's nothing. It's error propagating back to internal hidden layers. Then again, you have to compute the hidden layer weight, adjust the weight. Then again, it goes to the input layer. Then adjust the weight. So here the data flown from left to right, then right to left, then left to right, and right to left until you get your desired output from the neural network, right, or from the system you want. So thank you so much.